Behind the design, polypropylene. This client needed a custom orthotic to fit a variety of footwear styles and to apply a number of intrinsic and extrinsic variables and address patient symptoms and identified risk factors. The aim of this orthotic was to fit the maximum number of footwear styles worn by the patient while achieving the prescription variables required. They used the DOLA Custom Orthotic service. They selected the direct milled polypropylene shell from the shell material options in the detailed scripting section on the DOLA Custom prescription form. Polypropylene is our client's most popular material choice for their orthotic shells. It is a Shank independent material, direct milled out of a block of polypropylene with the offcuts recycled. It is available in a wide range of flex options, from ultra to extra firm, to suit all patient types and prescription aims. Polypropylene allows for both intrinsic and extrinsic shell prescription variables. Orthotip. 3D printed can be selected as an alternative to polypropylene. It is simply a different manufacturing technique. It is called additive manufacturing. It will produce a Shank-independent orthotic shell and aims for the same performance as polypropylene. Traditionally, polypropylene can be used as a thermoplastic material, heated and vacuum pressed to a positive cast. CAD-CAM involves direct milling both sides from a block of polypropylene and allows flexibility differences to be only a fraction of a millimetre. A polypropylene orthotic acts by resisting flexion under load of the foot and can be shaped, wedged, or angled to provide orthotic reaction force as required. It will appear as a thin piece of plastic with uniform or variable thickness over the entire device. Unlike EVA, polypropylene does not require to be in full contact with the supporting surface of the shoes at all points to maintain its shape or to provide resistance to load. A Shank-independent material. Therefore, the attributes of the shoe, the internal surface area, shape, and stiffness are less important than when using an EVA orthotic, a Shank-dependent material. A polypropylene shell will support the foot and the arch in a shoe with a narrow waist, as it does not require support from below to resist load. The medial and lateral arch will still support the foot without touching the supporting surface.